Hello friends, today we are going to discuss about the Newton's rings. So this is the construction of this the Newton's rings apparatus. This is microscope. This is the B and G are the two glass plates. The B plate is inclined at 45-degree angle. This is the source. This is the lens L1. This is the plano convex lens. So in this the when plano-convex lens of the long focal length is placed on a plain glass plate, a thin film of air is enclosed between the lower surface of the lens and the upper surface of this plain glass plate. The thickness of the film is very small at the point of contact and gradually increases from the center outside. When viewed with white light, the fringes are colored. With monochromatic light, bright and dark circular rings are produced in the air film. So, when the light from the monochromatic source, yes, incident on the lens L1 as I shown in this figure, the horizontal beam of light falls on this glass plate B, which is 45-degree angle. The rays becomes parallel and incidenting on the glass plate B, which makes an angle of 45-degree with the incident rays. The glass plate B reflects a part of the incident light towards the air film enclosed by the lens L and plain glass plate G. The reflected beam from the air film is viewed with the microscope. Interference takes place and dark and bright circular rings are produced is called Newton's circular rings. So these are the dark rings and these are the bright rings. So these are arrangement these bright and dark rings called as Newton's rings. So when the uh, Newton's rings are formed by the reflected light. The for the bright rings, the T equal to 2n minus 1 into the lambda by 4, and for the dark ring the thickness T equal to r square upon 2r. For the bright ring, radius r equal to square root of 2n minus 1 into the lambda r upon 2, and for the dark ring r equal to square root of n lambda r. So the Newton's rings formed due to the interference produced between these rays coming from the source S, which is uh, falls incident on this lens L1, which makes the beam parallel, and which is incident on this glass plate B, which is kept at 45-degree angle, and then it is reflected towards this glass plate L, which is kept on this lens L and this glass plate G. The contact between lens L, this is a plano-convex lens, and glass plate, here air film is formed. When the rays are incident on this glass plate, then they reflected towards the glass plate B, then rays coming from this glass plate B and rays reflected from the surface of this glass plate G, which are here the interference formed, and we can observe the Newton's rings, that is bright and dark rings formed, the rings called as Newton's rings, through this microscope M. So these rings alternately formed, that is dark bright dark bright dark bright, these rings are formed, and this is called as a Newton's ring. So this is about the formation of the Newton's rings, like this. The and the this arrangement, source S, lens L1, B and G, those are the glass plates. This is kept at 45-degree angle, and this is microscope M through which we can observe the rings and this lens, plano-convex lens, is kept on this glass plate G, and the interference formed the formation of the Newton's rings. So this is about the formation of the Newton's rings. Thank you.